Hello guys, today I'll be showing you guys how to calculate the Thevenin's equivalent circuit for this particular circuit that I have here. To calculate Thevenin's equivalent circuit, we need both R Thevenin and the V Thevenin values. The R Thevenin value will be equivalent to the total amount of resistance in the circuit when the sources are removed from the circuit, and V Thevenin would be the voltage that appears right at this terminal. Okay, so let's go, but before I should mention that this circuit has two independent sources. Because it has two independent sources, we're going to calculate it with a particular method. If it was otherwise, for example, if it has a dependent current source or a dependent voltage source, we would have to change our method of calculations, which would include like exciting the terminal here with like a voltage or a current to find R Thevenin. But in this particular circuit, we don't need to do that. So we are going to calculate based on Thevenins Theorem. So according to Thevenins Theorem, to calculate the equivalent resistance, which is R Thevenin, we need to remove any current source and replace it with a open source, and replace any voltage source and replace it with a short circuit. So let me give you guys a view of how it would look. This is how it would look when both independent sources were removed from the circuit. So as you can see here, it's an open circuit where the current source was, and now is a short circuit where the voltage source was. So having removed all the sources, we are able to calculate now the R Thevenin, or the equivalent resistance, which is present in the circuit. So as you can see from the formula here, R Thevenin will be equal to the parallel branch, which is R1 parallel to R2, and the series resistor R3. Okay, let's proceed with our calculations. Okay, from our calculations, we have found R Thevenin to be equal to 4 ohms from the values that were plugged in to R1, R2, and R3. Okay, since we have found R Thevenin, it's time for us to proceed to the circuit, find V Thevenin. Now, let's analyze the circuit. From the circuit, you can see that we have a parallel branch here and we have a series branch here. Please note though that in this configuration, no current will be flowing through this resistor, so we can ignore it in our calculations as it doesn't have a complete path for current to flow. So we are going to be focusing particularly at this node right here, because this node will give us the voltage that will be dropped across this resistor, which will tell us what voltage will be appearing here. So this voltage would be our V Thevenin, as it is a parallel, it's parallel to this terminal here. Okay, so let's proceed. As you can see here, from this node you have 2 ampere going into this node, and you have L1 going into this node, and you have, oh sorry, that's not L1, that's I1 going into this node, and you have I2 leaving this node. So based on Kirchhoff current law, the current entering into the node should be equal to the current leaving the node. So in this case, I1 plus 2 would be equal to I2, which is leaving the node. Okay, let's proceed with our calculations. From this equation that we have here, we are going to substitute Ohm's law into the into I1 and I2 to get the nodal voltages. From the circuit, you're going to see that from the substitution we have 32 minus V Thevenin over 4, that's for I1, and I2 would be V Thevenin over 12. Let's go back to the circuit. So I1 would be 32 over V Thevenin, which is there. So it would be 32 over minus V Thevenin over 4, and I2 would be V Thevenin over 12. So let's continue. Continuing our elimination, we are getting rid of the fractions now, and we are presented with this value. So continuing down, we are presented with this algebraic expression, which after computing successfully, we obtained a value of 30 volts for V Thevenin. Since we arrived at the values for R Thevenin and V Thevenin, we are able to show you guys what the equivalent circuit would be. So this is the equivalent circuit according to Thevenin's rules, or Thevenins Theorem. We have R Thevenin being 4 ohms, and we have V Thevenin being 30 volts. So guys, that is the equivalent circuit using Thevenins theorem for our circuit. Thank you guys for watching.